Well, thank you very much, Vitaly, for that lovely introduction. Hopefully you can all see my slides okay. Yeah, that looks like it's all good. So yeah, it's a real privilege to be here at another smashing meetup. I think the last one I spoke at was a couple of years ago, and I'm really glad to be speaking alongside Jerry McGovern too. He's somebody whose work I really admire, and hopefully we can have some interesting conversations and you can all learn a bit more about digital sustainability. So today I want to talk about the role that we as web designers and developers can play in building a more sustainable web. And as Vitaly mentioned, I'm a front-end developer at Ada Mode, which is a data science company working in renewable energy and green technology. And I feel very lucky to work in green tech because I enjoy feeling like I'm contributing my skills to something positive. But you don't have to work in the climate tech industry for your work to have an impact. Now, I hope the fact that you're all coming along to this talk and this meetup today means that you already care about climate change and I don't have to persuade you why it's important. But I just want to show you an example of why it's important to talk about digital sustainability. So this is the COP28 website, the COP Climate Conference, which is going on at the moment in the UAE. I have the network panel open on the right-hand side. And when I load the page, I'll just play you this video. Watch what happens in that network panel, especially the numbers at the bottom. You can see, it's very difficult to see the exact numbers, but they're basically increasing, going up and up. It's still going, still loading. This is just single page load. Eventually we get to 20 seconds and finally the page is loaded. Altogether that's 34.7 megabytes of data transferred and 683 requests. And yeah, this was my face when I loaded the page in that network tab. It's quite eye-watering. And also, just to point out, they do have a low carbon toggle on this website. If you toggle the switch up in the top left corner, that switches the website to low carbon mode. What the low carbon mode does is it just doesn't load the images, which maybe saves you about sort of 1 or 2 megabytes of data out of that huge 37 megabyte page load. So yeah, that's one example of why we need to talk about this a bit more, because this is not uncommon and it's particularly depressing for a website for a big climate conference like this. So yeah, why web sustainability and why do we need to do something about the environmental impact of the websites that we build? Well, we're already seeing the effects of climate change being played out. People are being displaced, ecosystems are being lost. And faced with the scale of this problem, it's very easy for us to throw our hands up in despair and say, the problem is too big, there's nothing I can do. But in fact, we have more power than we might realize. Most reports estimate that the internet accounts for around 2 to 4% of carbon emissions worldwide. And that puts our industry on level pegging with the entire air travel industry or a small country. And one way that we as web designers and developers can have an impact is reducing the amount of CO2 generated or carbon emissions generated by the websites we build. And in fact, carbon emissions are just one facet of the sustainability implications of our digital lifestyles. They're perhaps the most obvious one because the environmental impacts of greenhouse gas emissions are well documented, but there are a number of other interlinked issues. So there's e-waste. Vast quantities of old devices are dumped in landfill without being recycled, and many end up in developing countries where they damage soil and ecosystems and pose a hazard. We tend to think of the cloud as being clean, but in fact, the cloud is these huge data centers being built around the world and sometimes, built in the desert, and they require ever increasing amounts of power, but they also need a lot of water to keep them cool. And manufacture of computer chips also uses a lot of water. Water scarcity is becoming more and more of a pressing issue. There are harmful chemicals used in the manufacture and disposal of our devices and digital infrastructure, and these often end up in the environment. And mining the raw materials for manufacturing devices is hugely environmentally destructive, destroying landscapes and communities and resulting in biodiversity loss. Not to mention that this often occurs in developing countries without adequate labor protections. Poorer people are most likely to suffer the impacts of our digital lifestyles and least likely to benefit. Climate justice is a huge topic, but one that feeds into every part of digital sustainability. And we'll talk a bit more about that later on. So we need this kind of holistic thinking when we're talking about web sustainability, but we are going to start by talking about carbon emissions or CO2 emissions, because it's perhaps a little bit more easy to quantify than some of the others. So greenhouse gases are emitted at every stage of our digital lives, everywhere where energy is used, from device manufacture to powering data centers and digital infrastructure, and powering our devices and those of the end user. Now, as an industry, we've become increasingly concerned with web performance, and it's no secret that web pages have become increasingly bloated. The average web page size now stands at around 2 megabytes. And that's terrible for our users, whose experience of browsing such bloated sites will be terrible on slow connections. And that's a big concern, but it's also terrible for the planet. So poor performance and energy intensity often go hand in hand. But the good news is that fixing our website's performance problems will go a long way towards reducing its carbon emissions. There's a big overlap, and it's beneficial to everyone, your users and your company's bottom line, because faster websites lead to users getting stuff done. So you might have heard about performance budgets before. They're not a new idea. The idea that you identify things like maximum size of resources you're willing to load or maximum number of requests, and you can make choices and trade-offs about what you include on your website to ensure you stay under budget. And there are plenty of tools to help you measure your website's performance. So Web Page Test is one of them. And in fact, Web Page Test has a brand new tool called Carbon Control, which also allows you to estimate the CO2 emissions of your website, which is pretty cool. There's also Page Speed Insights by Google, and GT Metrics is another one. So that's just a few examples of tools for measuring performance. And with these, you can measure your core web vitals, which Google actually takes into account in its search ranking algorithm. So in my experience, this can help you make a stronger case to clients, because they'll maybe think twice about asking you to add additional resources to your web page if you can demonstrate the impact on their Google search ranking and on their bottom line. So, in my experience, once Google started taking these into account, when I was working at an agency, clients started to care more about performance. And it would be great if we could do a similar thing with our carbon emissions too. So if we're focusing on carbon emissions, not just performance, then we should maybe consider setting a carbon budget. A performance budget gets us some of the way there, but a carbon budget enables us to think about our sites holistically beyond just the metrics associated with performance. Now, it's pretty hard to measure your website's carbon emissions, as there are so many factors to consider, so many different variables. But there are a few tools that help you do this, or attempt to do this. This is Website Carbon, so it provides you with a quick snapshot quantifying emissions for 10,000 or 100,000 or however many monthly page views, and it tells you how green your site is compared to others and some actions you can take. And it's quite useful to see comparisons to the physical world, as it makes it a bit more real, a bit more tangible. So over the course of a year, it tells me that my own website homepage produces the same amount of CO2 as 987 cups of tea. Incidentally, I ran the COP28 website through this tool, and it came out rated F, which is like the worst carbon rating of them all, although apparently it was running on sustainable energy. So that's something. Now, for a more in-depth evaluation, you could try EcoPing. So this one is integrated with Core Web Vitals too. I haven't used this, but I know a few people who do, and it seems like it would be quite useful for reporting to clients. And Beacon is another one which falls somewhere between the two. Now, what I like about this is it shows the amount of CO2 produced on a returning visit as well as the initial visit. So you can see how effective your cache strategy is. Now, tools aren't the be-all and end-all. They can't tell you everything because they're based on data transferred on initial page load. They don't take into account things like lazy loaded images, JS, and data fetched during interaction. So they can only be estimates, but they are good starting points. And I would love to see these kind of metrics integrated in some way with dev tools for greater visibility. I think that would be really helpful. Now, once we have some idea of the environmental impact of our website, we can start taking steps to reduce it. And if designers and developers collaborate from the get-go, then we can do a much better job of this. Of course, page weight, or the amount of data transferred, is a big contributing factor. And one of the biggest contributors to transfer size tends to be images. So remember how we said the average web page size is 2 megabytes. Images alone account for nearly half of that. They account for 43% of bytes transferred and 30% of requests. Image data has to be stored and transferred, and they also need to be decoded and rendered by the browser. So images are a great opportunity to reduce the environmental impact of our websites. So what can we do here? Well, we can use fewer images. Can we design our web pages to have just as effective an impact with fewer or perhaps even no images? Or can we use SVGs instead of photos, as SVGs tend to be a lot smaller? Can we think about making our images smaller? Do we really need a full-width hero image? As an example, reducing the width of this image from 1200 pixels to 800 pixels reduces the file size by 41%. We should also optimize our images, so size and compress our images, ideally before uploading. And you can often reduce the size in programs like Photoshop by quite a large amount without any visible loss of quality. And of course, you can also compress your images at build time, either on the server or with build tools. So saving this one in Photoshop with a quality level of 4 rather than 6 reduces the file size again by a further 69%. We should also serve appropriate images for the user's device. So use the source set attribute on the image element so that users with smaller screens or lower resolution devices don't have to download huge images. And use modern image formats. So WebP is an incredibly versatile image format, and it's on average around 26% smaller than PNGs and JPEGs. It can handle transparency, and it has excellent support. AVIF is a newer format and can reduce the file size even further, but it's less well supported. Using the picture element, we can provide WebP or AVIF images for browsers that support them, while providing a JPEG fallback for older browsers. We should also defer loading images until a user actually needs to see them. So until they actually scroll to that point on the web page with lazy loading. And we can do this using the native loading attributes in HTML. We don't need any JS libraries for this anymore. So if a user never scrolls to that point on the web page, then those images won't be loaded. And here's an example of that with the image element using the loading attribute with a value of lazy. Fonts are another large resource that can bloat our web pages. And of course, the most effective optimization is to not use web fonts at all, just use system fonts. But most of us quite like having nice fonts on our web pages, and we don't want them to look like they're stuck in the early 2000s. So what can we do with our fonts? Well, use fewer font files is the obvious one. So design our sites in such a way that we don't need more than 2 or 3 font files. And variable fonts are worth considering if you need multiple weights or styles of a font. So some variable fonts have multiple axes that can be adjusted. So you can have a number of fonts that look very different in your design, but they're all loaded from the same font file. So this is an example using Roboto Flex, which is a free Google font. And it looks like we have maybe like 4 or 5 different font styles on this page, but actually they're all from one variable font with the axes adjusted with CSS. So variable fonts are pretty cool. The file size tends to be a bit larger than the average font file though, but you need fewer of them. And we can use modern font formats too. So WOF2 is really well supported, and you probably don't even need a TTF fallback. You could probably get away with falling back to a system font. And the file size will be much smaller than a TTF file. The problem is a lot of variable fonts only come in TTF files, but you can convert them using this tool from Google. So I recommend checking that out. We can consider subsetting our fonts too. So subsetting is the process of creating a smaller font file by only including a portion of the glyphs. So if we know that our website only needs to be available in 1 or 2 languages, then we can remove the glyphs related to the other languages. And there are tools online to help you do this. Interestingly, there's a forthcoming standard called the Incremental Font Transfer Specification. This is a working draft specification for incrementally loading the portions of a font that are actually used. So you can't use this yet. It's not supported by any browsers, I don't think, but it's just something that's quite interesting that we may be able to do in the future. We should also self-host our fonts if possible and avoid third-party requests. Many of us, myself included, also quite often fall back to using Google fonts because they're just so easy to use. But this is a tool which enables you to self-host your Google web fonts. So that's worth having a look at. Now, another big culprit in making our websites slower and more environmentally damaging are third-party code embeds. So I'm talking about ads, analytics, tracking scripts, chat widgets, YouTube embeds, other social embeds, all of those kind of things. And I'm sure there are plenty more. There are a few things more depressing than spending lots of time optimizing your site, getting all your Lighthouse scores up to 100, only for somebody to come along and stick Google Tag Manager on there or a YouTube embed, and you just watch those performance scores plummet. And YouTube embeds are particularly bad. So here I have this super simple HTML page with hardly any CSS. And the file size is negligible. It's like less than a kilobyte. Now, if I load a video embed from YouTube, we get over 3 megabytes of data transferred and 29 requests before we even start watching the video. And over 800 kilobytes is just JavaScript. And in fact, this was last tested in May. I tested it a couple of days ago, again, with the same embed, and it's now over 900 kilobytes of JavaScript. So it's actually increased nearly a megabyte of JavaScript. And this makes me mad because, a company with Google's resources surely is able to make this better. They don't need this much JavaScript. And it's so easy for a user to embed a YouTube video on a website. They just copy the embed code. They're not going to be aware of the impact of this. So the responsibility is on us developers and the developers at companies like this to be doing better, I think. So what can we do about it? Well, obviously we can avoid embeds where possible. That's not always possible because many clients want that functionality. So we should defer loading scripts where possible using the async or defer attributes. And we can lazy load iframes now. That's supported across almost all browsers. I think Firefox now supports it too. Google could add this to all their YouTube embed codes by default. And the other thing we could do is not load these resources until a user interacts with them. So only load a chat widget or YouTube video when a user clicks on it, when they've made an active choice to engage. And this is known as import on interaction. And with YouTube videos, you can provide what's known as a facade. So a static image, the user clicks on it and the video loads. There's an easy way to do that with Paul Irish's Light YouTube embed library, which is available on npm. Now, Google Analytics and Google Tag Manager are pretty bad for the performance and carbon footprint of your website. Plus, all that data has to be stored somewhere in data centers that consume electricity and water. So if you need analytics, consider a more lightweight alternative. And here are a couple. So there's Cabin and Fathom. And the great thing about using either of these is you also don't need to put a horrible cookie banner on your site too, which is also a win. If you have to use Google Analytics, make sure you only load the script when the user has consented, which you should also do for GDPR reasons. With this tool, Are My Third Parties Green, you can check how much data transfer on your site comes from third-party embeds, as well as whether they use green hosting and are cached effectively. We've talked about things like images and fonts, which can account for over 70% of bytes downloaded, but not all bytes are created equal. One thing we could do that can have a very big impact is use less JavaScript. JavaScript has the greatest negative impact on performance. Your browser has to do more work to process JavaScript. So don't be like this guy. And thank you, Andy Bell, for this image. We need to use JS responsibly. Design plays a big part in that. Can your web page have just as effective an impact without, say, a hero carousel? Remove libraries you don't need. Can you use a native API instead? Do you need polyfills? Can you remove any? Do you need to transpile your code? Transpiling your code for compatibility with older browsers increases the amount of code you're shipping. Modern browsers support ES6 features and have done for a number of years now. So look at your user base. Can you drop the requirement to transpile for IE11, for example? And embrace the web platform. Do you need a framework? Frameworks are a developer convenience, and sometimes they enable us to write better code and deliver better user experience, but in many cases they're overkill. So using React or Vue or whatever your framework of choice is, you're forcing the user to bear the cost of importing that entire framework's JS. So prioritize user experience over developer convenience. And I really recommend this book, Responsible JavaScript by Jeremy Wagner, which goes into some of the techniques I've mentioned here and a few more besides. So what we should be doing is optimizing everything we can. So cache what you can, so on the server or use a service worker. And this is a great article by Harry Roberts about cache control, if this is a new world to you. Minify and compress your code. So use build tools to minify, compress images, reduce JS transfer with gzip or Brotli compression. Tree shaking is the process of removing dead code, which can be done with build tools. And code splitting, too, you can do with build tools. So splitting your code into smaller chunks and loading them when needed. And that's a bit like what we looked at with the import on interaction pattern, but we can do it with JS libraries that we need for particular parts of our site, or import on a per route basis if we're using a framework. And we can use a dynamic import syntax to do that. So this is how we might normally import a dependency, a static import. So I'm importing the auth module from the AWS Amplify auth library. But instead, we can use a dynamic import, and this is a promise-based syntax. So bundlers will compile this import into its own module so that it's only loaded when this code is run. Now, this assumes you're using a bundler. Import maps are quite new, and they can do basically this, but without a build tool. I'm not going to go into exactly how they work here, but if you're not using a build step, then that might be something that's worth looking at. Audit your dependencies, so make sure you're not importing dependencies you don't actually need, and where you can, only import the modules you need from a library rather than the whole thing. And many libraries are written in a way that allows you to do that. Now, so far we've looked at ways we can optimize the code shipped to our user, which can have the benefit of making our websites faster as well as less carbon intensive. And these measures can help reduce energy consumed by the end user's device if we can enable them to download fewer resources and run fewer CPU-intensive operations. They can also prevent users needing to upgrade their hardware so often if their batteries and devices last longer. And less energy is consumed by data centers and networks from storing and transferring data. But there are also some measures we can take when it comes to the design of our websites that aren't related to web performance, but specifically reduce energy consumption on the user's device. There's the energy efficiency of our color scheme. So blue colors use more energy than reds or greens by up to 25%. And on OLED displays, black or dark pixels are off. So you might want to consider a dark mode for your app. There's the user journey too. So how much time are users spending on our site clicking around, loading more resources than they need because they can't find what they're looking for? So make your copy relevant and to the point. Invest in UX and content design. Use consistent navigation patterns, or consider implementing a search module that enable them to get what they need faster. We can also look at the infrastructure of our website. So how is data stored and moved around the network? And one step we can take is choosing a web host that uses renewable energy. Now, this is perhaps a bit less straightforward than it sounds, because it can sometimes be difficult to distinguish actual green credentials from greenwash and marketing speak. Plenty of companies claim to be green or 100% renewable, but in fact, they're just buying offsets or carbon credits. And of course, you need to balance various needs, like being able to deploy efficiently. The Green Web Foundation has a directory of hosting companies that provide proof of their green claims. We can look at the timing of processes on the server. So maybe scheduling energy-intensive processes for off-peak times when the carbon intensity of the grid is lower. We can run server-side processes during the night, for example, when there's less electricity demand, or when more electricity is being generated from wind or solar power, as the proportion of those resources fluctuates. This is an example of the Branch magazine website. When a lower proportion of the electricity is coming from fossil fuels, this is what the user will see. You'll be able to see the images, and it has this green color scheme. But if there's a higher proportion of fossil fuel generation on the grid, then this is what the users will see instead. It's got this yellow color scheme and the images aren't downloaded. Another option is to serve assets closer to where the user is. So use a CDN, content delivery network. The trade-off is you might not have as much control over whether those data centers use renewable power. I mean, you could use locations that have a higher proportion of renewable energy on the grid or lower carbon intensity. That would be the ideal. And there's an interesting case study by the agency Us2, where they built their own green hosting network, hosting in locations around the world with a higher proportion of the electricity coming from renewable sources. And you can see in this graph the huge drop in their carbon footprint of their site compared to hosting with Netlify. If you look at that black line in the sort of final sixth of the graph, it just completely falls off a cliff to almost nothing. And that's when they switched to their green hosting network. So obviously, building your own hosting network is not practical for everyone to do. But I think it's a really interesting case study, and I love seeing examples of these things. And perhaps it's your kind of thing and you want to run with it. Now, this responding to shifts in carbon intensity is called demand shifting, and it can result in between 45% and 99% carbon reductions. The Green Software Foundation has plenty of resources on this. There's one area that we don't tend to think of as having a big environmental impact, and that's the actual development process, the power used when running a site locally. And across a big organization, that could be significant. So this is a quote from Eric Bailey. He says, "If I was a better programmer, I'd write a script that shows you the cumulative CO2 you've generated every time you type npm install." So if your project is on GitHub, or if you're building a library on npm and it's downloaded by hundreds or thousands of developers, that can add up. So what can we do about our developer tool chains? Well, maybe we should consider a static site in certain situations. Does your website need to be a full-blown WordPress site or single-page application? Will a static site suffice? We talked about running tree shaking and optimizations in our build process, but we should avoid running those during local development, as it's a waste of resources. We should remove unused dependencies from our projects so that they won't be installed by others. I don't know if you've ever looked at a graph of your dependencies of your npm modules, but it's sometimes pretty scary how many dependencies and other dependencies of dependencies are being downloaded. So remove dependencies that we don't need. And reduce complexity in our tool chains where possible. So sometimes you might not even need a build step if it's a very simple site you're building. Developer Danny Van Koten wrote a case study about how he removed a 20 kilobyte dependency from his WordPress plugin, which is used on over 2 million websites. And he estimates he saved the equivalent in carbon emissions of 5 flights from Amsterdam to New York. Now, why do these individual actions matter? Some people feel quite defensive when you encourage them to take action on climate change at an individual level. And that's not just climate change deniers, but people who feel that the advice is misdirected and that it's the responsibility of corporations and governments. And yes, to some extent, that's true. I think we shouldn't let them off the hook so easily. I believe that those with the broadest shoulders should bear the most responsibility. But unfortunately, we live in a capitalist, profit-driven society. I believe we should have industry-level regulation and government-led action. But the fact is, nothing is going to change unless we act at an individual level too. So we should absolutely put pressure on big companies to reduce their emissions. But it lends more weight to our arguments if we can demonstrate an appetite for individual effort too. It makes it harder to dismiss our calls for action as a niche interest. It amplifies our voices. And making seemingly small changes to improve the carbon footprint of a website, even a small one, is a great starting point for having those conversations and demonstrating things that could have an even greater impact when done on a wider scale. And even if you don't believe in reducing the environmental impact of your website as an end goal in itself, there's an increasing amount of regulation in this area as governments and companies commit to net zero strategies. So in the UK, government contracts require commitments to sustainability, for example. And one of the ways we can be most effective is within our own areas of expertise. This quote comes from an article titled "Debunking the False Choice Between Individual Behaviour Change and Systems Change." It says, "Cultural revolutions don't happen because of systems change. They happen when a group of people voice a compelling story that propagates across society and becomes a social norm." So individual action drives bigger changes, and bigger changes wouldn't happen without it. But individual doesn't mean alone. And if there's one thing that web developers should be good at, it's building networks. It's when we pool our resources and work together that we can have the most impact. A supportive community can inspire and motivate us to go beyond what we can achieve individually. Our industry has bought into this myth of the lone wolf or rockstar tech genius. But I have some bad news. No single individual is going to solve climate change. It's a systematic problem, and it requires collective action and cooperation to affect change. So how can you get involved with taking action on a community level? One thing you could do is form a workplace action group to support each other to take climate action and push the climate agenda and greener practices within your organisation, as well as sharing resources and holding each other accountable. These things are easier to do when we band together. You can share your knowledge by writing, by speaking at events, and sharing on social media. Or you could join another community. ClimateAction.tech is a community of tech workers working together to seed climate action in companies and organisations. So if you want to learn more about tech's role in climate change and how you can take action, as well as have conversations and share ideas with like-minded individuals, this is a great place to start. There's also the Sustainable Web Design Community Group, who have been working together to publish a set of sustainable web development and design guidelines. And those have the first draft of those guidelines was just recently published, I think a month or two ago. As tech workers, we're in a position of relative privilege compared to workers in many other industries. We have the power to make our voices heard and push for change. And the products we build can impact a lot of people. And as important as it is to introduce sustainable practices, we need to do so through the lens of inclusion and accessibility. We need to ensure that the action we take doesn't adversely impact the experience of already marginalized people. We need to think beyond carbon emissions and climate change alone, because they're part of a bigger problem. We need to think about climate justice. We know that the richest 10% are responsible for almost 50% of total emissions, and we know that a huge amount of technical waste is dumped in developing countries, and that many of the components used in our devices are mined and manufactured in poor conditions, causing environmental damage. How many of us are upgrading our devices every couple of years? And are the web products we're building encouraging unsustainable consumption? You know, we can spend all day long optimizing our sites and making them super fast and super efficient and low carbon. But if those websites are websites for car manufacturers and aviation companies and fast fashion, then are we really putting a net good into the world? We need to ask ourselves some uncomfortable questions. As developers, we're used to using technology to solve problems with clear success criteria. But we have to acknowledge there's no quick fix for climate change. We don't have all the answers. No one's ever going to say, well done, you fixed it. It's messy and it's ongoing. And sometimes the solution isn't more tech. Sometimes the answer to a problem is the low-tech solution. There are some reasons to be hopeful. So this is a graphic from Hannah Smith at the Green Web Foundation. On the left is what people think about when it comes to building a more sustainable internet. So there's efficient tech, using renewable energy, and buying offsets. And on the right, it shows that actually building a sustainable internet is so much more than that. It's about diverse tech workforces, regenerative business models, accessible tech, the right to repair, and much more. So yes, it can be overwhelming, but it also represents plenty of opportunities to engage and to work together to build the relationships that we need to create meaningful change. I recommend this book, Sustainable Web Design by Tom Greenwood, if you want to go deeper into how we can build more sustainable digital products. And I'll leave you with this quote by the American prison abolition activist Mariam Kaba, but it's one that's frequently cited by the environmental movement too. She says, "Hope doesn't preclude feeling sadness or frustration or anger. Hope is not optimism. Hope is a discipline. We have to practice it every single day." So let's work together to make a difference, because this planet is for everyone. And thank you for listening. This is my website, css-irl.info. I've written a bunch of articles on web sustainability, so I've provided a direct link there if you would like to read more. And yes, back over to you, Vitaly. Thank you for listening.
Thank you so much, Michelle, for the wonderful presentation and so many practical insights, and it's been very, 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 very useful. I actually have this conundrum in my head, actually, and this is really surprising to me, because as an industry, especially as web developers, we've been so obsessed with efficiency. I mean, we always are speaking about how do we compress, and well, not all of us, but most of the time we do care about efficiency. But I'm wondering, how come that we still produce so much waste, right? This is kind of, for me, this is almost a surreal thing, because we are thinking about how do we optimize networking and the CDNs and so on and so forth. But as a result, we still provide create so much waste. And I'm wondering at this point, maybe the reason for that is that very often teams just don't know what they should be aiming for. Because with web performance, we kind of have the lighthouse score. If we are green in core web vitals and we're lighthouse 100, probably good. But then it's still, you might still have every now and again, just a lot of images, or you autoplay video or anything like that. So I'm wondering, is there a sort of a sustainability? I mean, obviously you also mentioned website carbon as well, but is there sort of a way to establish sustainability budgets? How would it look like? What would that be, or does it differ depending on the type of site? How would you approach something like that?
Yeah, I think it's very difficult to quantify it exactly, because so much depends on not just the amount of data transferred or things like that, but there's also the end user's devices and how efficient they are. It's very difficult to say this website produces exactly this amount of carbon. I think actually having those metrics integrated with things like Lighthouse and other tools that developers are familiar with would be really helpful, or at least make it more visible. I mean, can you imagine if Google put in the work and said, actually, our search ranking algorithm is also going to depend on how carbon intensive your web page is? That's a big incentive for people to do something about it. But I think also perhaps it's slightly less related, but I think maybe the problem is that our tech is becoming more and more efficient, and it's like they say, when you add an extra lane to a motorway, build an extra lane on a motorway, all that happens is that just gets filled up with traffic. It doesn't actually lessen the traffic that's coming through. And I think that's maybe a little bit of the problem of our hardware getting more and more efficient, or like, you know, we get super fast broadband, or all of these things, is actually we're just filling it up with more stuff.
Yeah. And I think it's also, we often have this conversation around us when we're developing, when we're designing. We just happen to leave us to be sitting in front of wonderful machines, powerful machines, without massive constraints, because usually we don't throttle our network to like 3G or so. Maybe for testing, although that's a big maybe. But this is not what we do. And I think that maybe the thing that I kind of started to see or kind of feel, maybe to some people still, despite everything that's happening in the world, sustainability doesn't feel close enough. It feels like a distant problem that, you know, is covered by so many other problems that we have in the world as well. And so it seems like, oh, well, it's just not visualized, not visible. So I think, like, even, again, like what you're saying, if in the end we would have that integrated in DevTools, like sustainability metrics integrated in DevTools, or Lighthouse, that would be obviously wonderful. There was a question that also came from Path, I believe. Is there a way to estimate carbon emissions of a website or web page early, be it in a design phase or in early development phase? Do you, because if you just build, let's say, build out your components, so you kind of make some decisions around design system and so on, how can you connect it with the impact, sustainable impact? Maybe also from your work.
Yeah, I think that's really hard to do, because as I say, we can't like quantify these things exactly. And even with performance, I think that's quite hard to say as well, like how much is this, you know, adding this carousel going to impact on your performance? Yeah, it's probably gonna, you know, make it worse, but but we don't know exactly how much. So I think, like, personally, like, even though I wouldn't like set too much store by those numbers, even though I think they're good starting points, like measuring, you know, using those tools to measure your carbon emissions and say, like, okay, these are the areas that we can improve on. I think they're good starting points, but they can't ever be exact. And I think there would need to be so much work done to make them really accurate that you can't place too much faith in those. You just kind of need to know that, yeah, if you're loading lots of resources, if you're using a ton of JavaScript on your page, then it's almost certainly gonna, you know, make the carbon emissions of your website worse. So I think we just kind of have to apply similar thinking to what we do already with web performance, or what I hope we do already with web performance, where, you know, we're kind of pushing back against, you know, maybe gratuitously adding these carousels or loads of YouTube embeds or JavaScript. As we've seen, you know, not everyone has that way of thinking, but it's a bit more established in our industry, I guess.
All right. Well, thank you so much, Michelle, for your insights. We will bring you back to our panel as we will be moving to the next speaker, to Jerry. And then after that, we'll bring you back. Everyone, please give a warm round of what is your favorite dish, Michelle?
My favorite dish? Oh, my goodness. A pie.
A pie. So if there is I don't know if there is a pie emoji, but if there is one, or if you discover one, please send a wonderful round of pie emoji in the chat to Michelle. Thank you so much for your insights, Michelle.
Thank you.
See you a little bit later.